All right, I am going to go through this a little bit quicker than I usually do because I think y'all are probably pretty good with these at this point. For the first one, which is talking about the air conditioning unit, what's the first part of state? Population. And what are we defining as our population here? What is our population for this problem?
All of the new air conditioning units that are made by this new brand by this specific manufacturer.
And I probably should have put this manufacturer. Did it say this manufacturer in there? So I probably should have put manufacturer, but the new was the new brand, so it's all air conditioning units of this new brand. I should put this manufacturing unit of this manufacturer. So what comes next? Before that, parameter. What parameter are we defining? Mu. So because it's mu, we have to say mean. So it's the mean what? Kilowatts of electricity that were and used per day. And then now this was the answer key from before when I posted it. So I again wrote air conditioning units of this new brand. But do I really need anything past here? No. So I've already defined it, so that's fine if you don't restate your population and your parameter. So my null hypothesis is what? That what equals 6.5? Yeah. Mu equals 6.5 kilowatts. And then our alternative is mu is greater than 6.5 kilowatts. And the last thing I need for state, let alpha, which in this case is. And how did it give us our information for alpha in this problem? It gave us the significance level. So if it says significance level, it means alpha.
I used 7 instead of 6.5. Why is it?
You used the statistic instead of the parameter. Like our X bar was 7.
Okay.
All right, so plan, first step is what? Method. This is a one sample which decision? T, Y. Sigma is unknown, and then it is continuing to test for means. This is the one that I messed up in this class. I forgot to type the word random. You can't generalize your results. I don't really care what you write there because that was my fault. What's my next condition? Normal. How am I checking this one? Central limit theorem. So I would definitely state the word central limit theorem. I would talk about n being 50 versus 30. Show that that's greater than. And then finish with. So we can use normal approximation. And my last condition, independent, which is 10% condition. We end up getting that capital N has to be greater than, or at least what? Which is 500. So this is assuming there are at least 500 air conditioning units of this new brand. This is where it would definitely make more sense at this manufacturer. Which I think probably should have been in there. All right, what is my X bar? 7. What's my next thing I need? S, which is 1.4. What else? N is 50. Mu is 6.5. And then my last two things that I write. So one tail and alpha equals 0.05. So we're using our equation of X bar minus mu divided by S over square root N. Plugging in my numbers, 7 minus 6.5 divided by 1.4 over square root 50 should give you a test statistic value of 2.525. Again, like I said, this used to be an answer key, so I just did calculator notation, just showing steps. You should end up getting 0.0074, and this is when I taught it a different way where I didn't teach them to go up. So if I actually typed this one in the calculator, I would have done my lower is 2.525, my upper is 1E99. And then you want to compare your p-value to your alpha, and here we state that it is less than. So our conclusion, we reject the null hypothesis that mu equals 6.5 kilowatts since the p-value is less than alpha.
Can you go back to the? I got the 2.525, but then I didn't go.
You might have used your yellow sheet instead of your purple sheet. You should have used the calculator. Either run the entire test in your calculator, which I would have done.
Yeah, but then I just wrote it as 2.5.
You just didn't find your p-value.
So you gotta do 1 minus.
This class probably isn't going to do this. This class is probably going to go straight to that and not do 1 minus.
How do you find your p-value?
This.
It just gives you
The 2.525 is your lower. Yeah. And then your upper is what? And I would have to type in degrees of freedom.
And that was second distribution.
Yes. All right, so we reject null hypothesis that mu equals 6.5 kilowatts since the p-value is less than alpha, which means that we do have enough convincing evidence that the mean kilowatt of electricity used per day per air conditioning unit of this new brand is higher than 6.5 kilowatts. And again, I talked about what can I, very, very shorthand, what can I write here instead of my words? Which is and that is fine instead of this part right here. Questions with the first one? All right, second one. What is our population? What are our individuals? It doesn't ask this question. What are individuals? It's not a hard question. You can look at that really quick and tell me what the individuals are. The bottles. So my population is all the bottles, but it is all the bottles of the popular cola filled that day. And this one doesn't say manufacturer, right? I would probably say from this filling machinery. But it definitely only talks about this day. Correct. So parameter, let mu be the mean amount of cola, of the popular cola filled in all bottles on that particular day. Again, that would be fine. Probably want to say filled. And then, because you've already defined the rest of your population. So our null hypothesis is that mu equals 300 milliliters. Our alternative is that mu is not equal to 300 milliliters. It did not give us an alpha, so by default we use 0.05. I think I talked about this in class yesterday. I tend to write since not given. I'm not going to count off if you don't write that, but I just tend to basically say, hey, I looked for it and I didn't find it, and that's why I chose this. All right, so plan. This is a one sample what? T test for means because sigma is unknown. First condition is what? Random. What's slightly different about this one versus some of the ones we've done? It says randomly selected, which means what? So do I really need to write random selection if it already says randomly selected? So like that one, I don't technically need my parentheses thing. What is my next condition? Normal. And what do I know for this one? Stated population distribution is approximately normal. This is one where I said you could do it in context instead of saying population distribution. I think it literally in words said distribution of the contents. And then so we can use normal approximation. Independent 10% condition, our lowercase n was 6, which means our capital N has to be at least 60. I don't like that I used to do this. At least, and I should have written out more with the equation. assuming at least 60 bottles of this particular cola were filled on this particular day by this filling machine. What is our X bar? 299.03333, depending on how many you went out to. Our S equals 1.5029. We have a lowercase n of 6. How many tails? 2 tails. What do we need to find from this problem from n? I didn't write it in my last one, I don't think.
Degrees of freedom.
Oh, and my picture cut it off. It did say degrees of freedom over here. I just took my picture and missed it. Degrees of freedom equals 5. Alpha equals 0.05. It is 2 tail. So running my test statistic here, plugging in my numbers, I get negative 1.576. But since it is 2-tailed, I draw it on both sides, so I draw it as positive and negative. If I looked it up to find the p-value the old way, like plugging in and I would do negative 1 E99, and I would do my upper as negative 1.576, degrees of freedom of 5. If I did that, I would get this number, 0.0879. But I also want it here, so I need 2 of those. So if I do it by hand, I have to remember to multiply by 2. What would I do to get this answer directly? What would I have done differently to just go straight to this answer? An actual t-test, which means I wouldn't have to write these because I wouldn't have to multiply by 2. It would just go straight to giving me that. But either way, you should get a p-value very close to that, maybe off by 1 if you did it a different way. And our p-value is not less than alpha. Again, I've changed how I've done this over the years. I would much rather you write not less.
When I put all the stuff in for the p-value, I got like the 7.63 with the e like negative 13 on it.
I'm gonna look at your calculator then. I'll look at your calculator. It's easier for me to look directly at your calculator to see what you're doing as soon as I finish this. All right, so we reject the null hypothesis. Wait, we failed to reject the null hypothesis as the p-value. Again, here, I don't like the way I used to do this. There's nothing wrong with it, but it confuses people sometimes. I would rather you say what? Alpha 0.05, we do not have convincing evidence that the mean amount of this particular cola filled in all bottles this particular day from this filling machine was different than 300 milliliters. Questions?